Okay, guys, I'm going to start going over some of the stuff from chapter 2, 3, and 4 here. So just right off the study guide, like I said, these are going to be pretty direct notes. So to start with, some of the first terms are reviews from chemistry from last year for you. So atoms, elements, compounds, molecules, things of that nature. We'll look at these a little bit, and in the future we kind of look at things as molecules. But just so we understand kind of the differences here briefly, sort of the four core elements that we're going to look at are hydrogen, oxygen, nitrogen, and carbon. And if you notice, I wrote them in that manner for a reason, because it spells honk. One of the things on your study guide is the honk rule. Honk rule tells us how many bonds form for each of these. So for example, hydrogen forms 1, oxygen forms 2, nitrogen forms 3, carbon bonds 4 times. And so what that means is in a majority of the cases, like 99.9% of the time, this honk rule applies. So for example, if I have a molecule, and a molecule like methane, CH4, a couple of things that we should kind of understand how to do maybe is to draw like valence electrons. We'll do this a little bit in class too, but if you look on your periodic table, carbon is in the 4th column. So that means that it has 4 valence electrons. So carbon, I would draw like C, and then if you remember, you probably did this in chemistry last year, you draw the electrons around the outside of it. Hydrogen is in the 1st column, so it only has 1 valence electron. So you're going to start to notice a pattern because the way that these bond also has to do with their valence electrons. I'm actually going to draw 4 hydrogens here, and I'm going to draw them in a specific way. I'm going to put one up here. Should have drew that a little bit lower, but so when methane forms a molecule, these are each individual atoms. So these 5 atoms are going to form this molecule. These 2 electrons are going to form a bond. These 2 electrons are going to form a bond. These 2 and these 2. And so we can rewrite this molecule as CH4, something that looks like this. And so you're going to see things like this, understanding that there are 2 electrons at each of these bond points. For bonds to occur, needs to share at least 2 electrons. So these are being shared between these 2 atoms in the molecule. A couple things from the periodic table here to go along with this is like the weight of this, because the weight of these, again, not something we're going to do a ton of, but we need to understand kind of the idea behind it for some of the things that we look at. So if you look on your periodic table, carbon has a weight of about 12, and hydrogen has a weight of about 1. So these are known as atomic masses. They're actually measured in AMUs, but we're not going to like really refer to it in that manner because it's not super important for us in this class anyway to understand that. But if you have 4 hydrogens, you basically multiply that value by 4. So that's why I've drawn 4 of them here on the right side. And then we total that up. So 12 plus 1 plus 1 plus 1 plus 1. So we get 16. So methane has a mass of 16. And that mass can be represented with grams per mole. I'm sure you guys love learning about that. So it can be grams per mole, or it could be in this AMU unit. There's a couple different ways that we kind of look at that, depending on how we are evaluating the molecule itself. So another term on your guide is compounds, and you also have molecules there too. I'm going to refer to pretty much everything as a molecule because that's what we're going to be dealing with. But a lot of these can be considered compounds as well. So for example, this could be considered a compound. And the big difference is like a compound can have 2 different elements, and molecules will only have 1 type of element. So for example, nitrogen, N2, this is a molecule. A bigger molecule might be something that is like C60, so 60 carbons. That's like a large carbon based structure. A buckyball is another word for it. Just there so that like we don't get tripped up on it. The last thing I want to point out is single, double, and triple bonds. So this is part of the honk rule as well. So if we have something like C2H2, we'll get used to drawing these molecules. One of the things that we try to do is carbon usually bonds with itself, and then we would expect that hydrogens would be split, something like that. Now you'll notice that this does not fulfill the honk rule because carbon needs to have 4 bonds with it. So hydrogen can only have 1 bond. So these are done. Check, check. So we have to add in some more bonds here. So if we add in a second bond, this would be a double bond. So that would be a double. There's 2 lines. That is the same as 4 electrons. But then if you look at like this carbon right here, I'm going to highlight in yellow. This guy only has 1, 2, 3 bonds. And the same would be the case with the other carbon. So we actually have to add in another bond here. So we make this a triple bond now. And that means that there's 6 electrons being shared there. We'll practice this a little bit in class too, but I wanted to make sure that I cover it here.